geobyte.
Similarly, let us take the another important problem on the Carnot cycle. A Carnot engine has efficiency 50%. When the source temperature is 327 degrees centigrade, the temperature of the sink is Carnot cycle efficiency equal to zero point 0.5, right? Source temperature, hot source temperature is given 327 plus 273. It gives 600 Kelvin. Sink temperature means cold source temperature equal to how much? Very easy problem. As you know, Carnot cycle efficiency equal to 1 minus cold source temperature by hot source temperature. Okay. From this cold source temperature by hot source temperature equal to 1 minus Carnot cycle efficiency 1 minus zero point 0.5 is equal to zero point 0.5. Then cold source temperature equal to zero point 0.5 into hot source temperature. It is equal to zero point 0.5 into hot source temperature 600. So it is equal to 300 Kelvin. But look at the options. All options are given in degree centigrade. 300 minus 273 for getting 27 degrees centigrade. That is the sink temperature. Is also called cold source temperature. Look at the option B. Option B is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem. Okay. Look at the screen. It is asking like this. An ideal gas follows a process described by the equation PV square equal to constant. Given equation is PV power 2 equal to a constant. From initial state P1 V1 T1 to a final state where the pressure is P2, volume is V2 and temperature is T2. Thermodynamic states where C is the constant. Then you are asked to decide relation between the pressure, temperature, volume temperature, pressure temperature, etc. Okay. For that, as you know, it is given for ideal gas. As you know, ideal gas equation is ideal gas equation is PV equal to N into R into T. From this, P equal to nRT by V. Let me write that value in the place of P. In the place of P, I can write nRT by V into V square equal to constant. One V is cancelled. Finally, it is, finally, it is, finally, it is nRTV remains constant. Dear friends, remember n remains constant and r also remaining constant. These two quantities are constants. Number of moles constant, universal gas constant are also constant. Therefore, Tv equal to constant by nr. This is another constant, let it be k. So Tv equal to k. Then from this I can write that. From this I can write that temperature equal to constant k by volume, or temperature is inversely proportional to volume, or volume is inversely proportional to temperature. What it means? If temperature is high, volume is low, right? Volume is low. That means if T2 is more than T1, if T2 is more than T1, I can write V1 is more than V2. Or if T1 more than T2, I can write V2 more than V1. Okay, look at the options. So A is not correct. If V2 more than V1, T2 more than, right, V2 more than V1. If V2 more than V1, T1 more than T2. T2 less than T1. Option C is absolutely correct. If V2 is more than V1, the T2 less than T1. Okay, option T2 less than T1 means T1 is more than T2. Option C is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important question. Try to read it. It is asking like this. An ideal gas undergoes four different processes from the same initial state as shown in figure. Look at the figure. Those processes are adiabatic, isothermal, isobaric, and isochoric. Here, isobaric means constant pressure, isochoric means constant volume. The curve which represents the adiabatic process among 1, comma 2, comma 3, and 4 is. Look at the given curves. Right, for the given curves, I can write that fourth curve is constant pressure process, means isobaric. One is constant volume, means isochoric. Here, if I assume this is a 0, 0 to 0 to 4, isobaric process. Okay. Similarly, 0 to 1, 0 to 1, isochoric process. Isochoric process. Then, among the 2 and 3, one must be isothermal, other must be adiabatic. Right? As you know, isothermal rule is isothermal rule is product of pressure and volume remains constant. Then you differentiate it on both sides. PdV plus VdP equal to 0. From this I can write PdV equal to minus VdP. Then dP by dV at constant temperature equal to minus P by V. The quantity dP by dV at constant temperature is the slope of isothermal curve, which is equal to minus P by V. The negative sign indicates as the pressure increases, volume decreases. Okay. Similarly, look at the adiabatic rule. Adiabatic rule is एक minute. Adiabatic rule is adiabatic rule is PV power gamma equal to constant. Now you differentiate it on both sides. P plus P, not plus, एक minute. P into gamma V power gamma minus 1 dV plus V power gamma dP equal to 0. Differentiation of constant is 0. Gamma P V power gamma by V dV equal to dV plus should be very careful, plus, right, V power gamma dP equal to 0. I can cancel this V power gamma. Finally, it is gamma P by V into dV equal to dV, or dP by dV is equal to, when you bring it to right side, it is becoming minus. dP by dV equal to minus gamma P by V. That is the slope of the reverse adiabatic curve. Look at the slope of the reverse adiabatic curve. It is gamma times the slope of the isothermal curve. So dP by dV for the reverse adiabatic process is equal to gamma times the dP by dV for constant temperature. Since gamma always more than 1, therefore the slope of the reverse adiabatic curve is more than slope of the isothermal curve. So dP by dV for the reverse adiabatic process is more than slope of the isothermal curve with the PV diagram. Now look at the right, 0 to 3. 0 to 3 is maintaining less slope, 0 to 2 is maintaining more slope. Therefore this slope may be minus gamma P by V. Here it is minus P by V. So I can say that this is the constant temperature process, this is the adiabatic process. So 0 to 2 is representing the adiabatic process. Since it is asking for adiabatic process, option A is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem. It is asking like this. The efficiency of a Carnot engine depends on option A, temperature of the sink only. Option B, temperature of the source and sink. Similarly, option C is the volume of the cylinder of the engine. No, the temperature of the source only. Carnot cycle efficiency equal to Carnot cycle efficiency equal to 1 minus T2 by T1, where T2 equal to sink temperature, sink temperature, T1 equal to source temperature. We can also write 1 minus T minimum by T maximum. Here T maximum means source temperature, that is T1. T minimum means sink temperature, that is T2. Anyhow, the Carnot engine efficiency depends on not only source temperature but also sink temperature. Option B is absolutely correct. Okay. Na? Similarly, let us take the another important problem. It is asking like this. The PV diagram for an ideal gas in a piston cylinder assembly undergoing a thermodynamic process as shown in figure. The process is, in the PV diagram, it is marked as a horizontal line, means the constant pressure, where the dp remains 0. Dp remains 0. That is called isobaric process. Isobaric process. Dear friends, remember, constant pressure process, other name is isobaric process, whereas constant volume, other process is isoporic process. So since it is isobaric process, option C is absolutely correct. Okay. Na? Similarly, look at the another important problem asking like this. Two cylinders A and B of equal capacities are connected to each other via a stopcock like this. The one cylinder, let it be cylinder A, and this is the cylinder B. Equal capacities means size of the cylinder A equal size of the cylinder B. Okay. Now these two are connected by a stopcock like this. A stopcock like this. Listen carefully, like this. A contains an ideal gas at standard temperature and pressure. A contains some gas. Some gas is there in the container A. B is completely evacuated. B is evacuated. Okay. The entire system is thermally insulated. The entire system is thermally insulated. Once the entire system is perfectly insulated, the heat transfer Q equal to 0. Then the system is coming under adiabatic system. The heat transfer, let me write it clearly. Heat transfer Q equal to 0 because it is perfectly insulated. Okay. Then the stopcock is suddenly opened, the process. Once the stopcock is suddenly opened, the high pressure gas is rushed towards the perfectly evacuated container. Right? That kind of process is called free expansion process. Free expansion process. Dear friends, remember, free expansion process is adiabatic, but it is highly irreversible process. So, free expansion process is irreversible adiabatic process. Adiabatic process. Okay, understood clearly? So, adiabatic process, but irreversible. Option A can be selected. Option A is absolutely correct. Understood clearly? Yes.
Geobyte.